This keynote presentation about PowerBuilder's cloud direction has been authored by John, Appeon CTO, and the narration is provided by me, Armin Mazda. Before we begin with today's keynote presentation, I'd like to briefly explain why I'm narrating for John. John's a really interesting guy. I've known him for many years, very bright, loves to read. He loves technology and especially loves PowerBuilder. And for those reasons, he's actually fluent in English, even though English is his second language. In fact, I'm a native English speaker and I'm frequently learning English words from John. That's how well read he is. But ironically, for the same reason why he's fluent in English, because he loves technology, constantly reading English books about the latest tech coming out of Silicon Valley. And also he loves PowerBuilder. So he's constantly in the office. We can't get him away from the engineering team. So therefore he doesn't get much chance to speak with foreigners and practice his English. So therefore his oral English is not to the level of his written English. Anyway, so I will be narrating for John. And this entire presentation that you're seeing has been authored by himself, including all the English on his PowerPoint. But I will be adding a few of my own commentary to help fill in some additional details that I think is important to share with you. So 2 years ago, we launched the PowerBuilder roadmap. The roadmap that we announced had two key areas of focus, .NET and the cloud. Now 2 years have gone by, and we're in a position to clearly tell you what PowerBuilder's cloud direction really is, beyond simply saying we're taking PowerBuilder to the cloud. This keynote presentation, we will be covering what the cloud really means today, the business benefits the cloud of today provides, and how PowerBuilder will help you get you there. So let's look at what the cloud really is today. In 2006, Amazon launched AWS. At that point in time, some enterprises started migrating applications from their own servers onto AWS's cloud platform. However, the architecture of those applications didn't really change much. They remained as monolithic apps, as they were previously when they were on-premise. Only the deployment environment changed. In that sense, a monolithic app hosted in the cloud, is it really the cloud? In our opinion, that's just fancy hosting. But today, 10 years of advancements have gone into the cloud, and what the cloud looks like today is radically different. So, what is cloud native? There really isn't an official definition that everybody agrees on. So what we have done is we've outlined two relatively respected organizations that each have their own definition of what cloud native really is. We have put forward definitions from CNCF and Pivotal. There are four key characteristics of a cloud native application. The app needs to be container packaged and deployed. The app needs to be microservice oriented. The third characteristic is that your containers should be dynamically orchestrated. And lastly, a cloud native app should be cross-OS, which can be deployed on a public, private, or hybrid cloud. Now, the second organization, Pivotal, they're really well known. They have developed a famous Java framework called Spring. You may know of it. And Pivotal's definition is a lot easier and simpler to understand. Their definition states that a cloud-native app should fully exploit the advantages of cloud computing models. So it's not specifically putting any characteristics. But let's just say the four items highlighted are some of the advantages of a cloud computing model. So therefore, Pivotal's definition is consistent with what we have outlined here. So we mentioned monolithic applications and how in the early days of fancy hosting, the apps remained as monolithic apps. So let's take a look at what is the difference between a monolithic app and a microservice app. A microservice app being one of the key characteristics of a cloud-native application. So a monolithic app is a single integrated software instance. Think of it as a single unit, a big chunk of stuff. Of course, you can divide into modules, and many monolithic apps do have modules, but those modules are tightly coupled. Because they're tightly coupled, the software is typically deployed as one unit onto a single physical server or virtual machine. The unit of deployment is the entire application. And the unit of scale is additional machines. Could be physical servers or virtual machines, but that's how you scale up your application. So let's take a look at microservice-based apps in contrast. Microservice-based apps are broken down into independent modules. They are loosely coupled modules, and each module is developed according to a microservice. These microservices can be developed by different teams. And they can even be developed with different technologies. Again, because they're loosely coupled, so they don't depend on each other. And microservices can be distributed across multiple different cloud providers, cloud technologies, data centers. Again, because they're loosely coupled. And microservices are independently deployed. And because they're independently deployed, the unit of scale is a microservice. So if you need to scale up your application, you can independently deploy certain microservices to additional servers or VMs. It's not deploying the entire application. So let's take a look now at a cloud-native implementation. We just talked about how cloud-native apps need to be microservice-oriented, and we had mentioned earlier in the definition of a cloud-native app that the microservices need to be packaged and deployed in containers. Well, there are two different examples of microservices in this implementation. One is a standardized or a third-party microservice. For example, an API gateway microservice or an authentication microservice. And then there are microservices that you have custom developed. So for example, the product service microservice or the order service microservice. A special characteristic to notice is that each microservice would have its data independent from the data of another microservice. So as you can see in this example, the product service has its own product database. And again, this goes back to the previous slide that we talked about, where each microservice is loosely coupled from other microservices. The containers of the microservice would be deployed in a container cluster. And the cluster would handle the dynamic orchestration functionality, which we had also mentioned was a key characteristic of a cloud-native app. Simply put, cloud dynamic orchestration means that based on policies, your containers dynamically will be scaling up and down. And this example is not using any proprietary technologies. The API gateway, the authentication service, the email service are all following open standards that are not specific to one particular cloud service provider. As such, this is a true cloud-native app in the sense that it is also cross-cloud. It can be hosted on AWS, Microsoft Azure, or Google, for example. So now let's look at an AWS specific implementation of a cloud-native app. This implementation is AWS specific, so of course we're using all of the Amazon provided services for the various pieces in this implementation. So let's take a look at the API gateway. We're using Amazon's API gateway rather than a generic open standard one. For the authentication service, we're using Amazon's Cognito. For the publish and subscribe service, we're using Amazon's SNS. For email service, we use Amazon's SES. And then the microservices that we developed ourselves are, of course, custom developed. They're not provided by Amazon, but they're deployed to Amazon Lambda. Notice again that each microservice does have its independent database. So even though we are using services provided by Amazon, we're still following the microservice architecture model where things are loosely coupled and independent. Now, Amazon Lambda actually implements both the container packaging and the container dynamic orchestration. So in fact, this AWS Specific Implementation is delivering on most of the key characteristics of a cloud-native app, except for that it's not cross-cloud, obviously, because it's using Amazon's implementation. But if we look at Pivotal's definition, they simply say you need to use all the advantages of the cloud computing model. And we are doing that. We're taking advantage of all that Amazon has to offer in this implementation. So depending on whose definition you go with, this AWS specific implementation is also a cloud native app. So you may be wondering, what's the big deal about the cloud? Why go to the cloud, especially all this cloud native stuff? It is more complicated from an architecture perspective, but the cloud has 4 key benefits. First is it's going to help you save a lot of time and money, and we'll be outlining why. The second benefit is it's going to help your business to become more agile, and we'll also be discussing that. The third benefit is that it's going to offer your business greater scalability and elasticity. And fourth is helps your business to remain competitive or even get an edge. So let's look at how the cloud native is really going to help you save time and money. If you're deploying on-premise, which is how things have been done pretty much across the board 10, 15, 20 years ago, you're basically managing everything yourself, from development to deployment to the infrastructure, which you can see they're all highlighted in green. These are everything you're managing, it's on-premise. Now, Amazon's AWS of 10 years ago, it was essentially delivering infrastructure as a service at that time. And this solved the application deployment headaches. Basically, you don't need to be responsible for virtualization, hardware, or networking. You're responsible for your application's runtime environment, for example, the operating system, middleware, any sort of runtime framework your application requires, such as a .NET framework. And then you're obviously responsible for developing your application and your data, or purchasing a third-party application data that's being hosted. Now, in more recent years, we have reached platform as a service in the evolution of the cloud, and that helps you save more time and money. The reason being is that in a platform as a service model, many more things are handled for you, including the runtime environment of your application. So you're basically focusing on just your application and your data. The provider is managing all the other pieces of your stack. Now, the most recent advancement in the evolution of the cloud is everything as a service. And that's sort of what we were alluding to in that AWS example that we had just covered. In this phase of this application development model, the way you're developing apps has just dramatically changed. You don't need to develop every part of your application. In fact, your application is built utilizing services, and these services can be developed by a third party, or there can be services developed by yourself. And of course, the whole software environment, runtime, middleware, OS, virtualization, all of that is inconsequential. You're not managing that. So the further we move forward with the evolution of cloud technology, more and more things are becoming services. You're doing less and less. And what that means is that you'll be focusing more and more on your business logic. So business agility is another key benefit of moving to a cloud native architecture. And one of the ways you achieve a lot of agility is actually from the microservice-oriented architecture of cloud native applications. A microservice is small and independent, so it's relatively easy to manage and involve compared to a monolithic app. And that does improve productivity, having things being granular like that. Now, the development work can be split across multiple teams, and these teams do not need to have close communication. So again, that opens up a lot more options, a lot more flexible ways of working, making businesses more agile. And what's nice is when a microservice has an issue, it's relatively easy to debug and resolve, because the microservices are loosely coupled. So when a microservice has a problem, it is a problem of that specific microservice. It's not relying on another microservice. And lastly, another key benefit is that you can take advantage of the latest technology in your microservices. What do we mean by that? You may have started developing a microservice today using a particular technology. Maybe at this point, Amazon did not yet offer the Amazon SES email service, for example. And then now time has gone by, they do offer that service, and you're developing a new microservice. You can take advantage of that latest technology that's available for this new microservice. And because microservices are loosely coupled and independent, you can pull together these different microservices developed with different technologies into your single cloud native app or cloud native implementation. But it's not an all or nothing kind of deal. Now, with microservices, there are some trade-offs. There's no free lunch. And so let's take a look at a few things. First is that the microservice architecture does have a longer learning curve than, for example, if you're just developing a monolithic application. And to deploy a microservice, it is more involved. There is more complexity. There are more moving pieces than, a monolithic application. And potentially a third con some will cite is that in a microservice architecture, you really don't have atomic transactions. Well, the first two cons Appeon will be addressing through the tools that we provide. The third con is not actually a problem because in a distributed computing model, we rely on eventual consistency. So in fact, atomic transactions may not even be an applicable approach to the microservice architecture. So we're going to take a look at how the evolution of the cloud increases the scalability and improves your elasticity. So as a first starting point, let's take a look at a physical machine deployment. In this situation, you're not in the cloud. How do you scale your app? It's manually done. You bring another physical machine and hook it up. Your unit of scale, it's a machine. It takes weeks to get a machine up and running and all the software installed. These are some typical numbers that we're generalizing. And generally, when you put a physical server live, it's going to at least live for a number of months before you would take it down, do repairs, or whatever. Now, when we start moving towards the early cloud where things were run on virtual machines, you're moving to a policy-based scaling. So that means that things are sort of automatically or dynamically scaled based on policies or rules that you've set. The unit of scale is a virtual machine. So everything you do are in that chunk. So you're still doing things at a machine level, just like the physical machine. And that's why we call this fancy hosting. It's one step up from an on-premise deployment. You'll be able to deploy in minutes. And so that is a big advantage compared to using physical technology. When you virtualize, you can get a new virtual machine up and running typically in minutes. And a virtual machine will typically live for weeks before it is brought down for servicing. So when we reach platform as a service and also start going towards cloud native technologies, containers is a requirement. Packaging and deploying your apps in containers. Now, containers, just like virtual machines, are also policy-based scaling. But the unit of scale is much smaller. Your unit of scale is a container. A container can be deployed in just seconds, and it typically would just live for hours. And finally, when we get to everything as a service, doing everything totally cloud native, taking advantage of serverless technology, then scaling is automatic. It's not even policy-based. You don't worry about scaling. The unit of scale is even smaller than a container. The unit of scale is a function. A function deploys in milliseconds, and a function only lives for milliseconds. In fact, the function is living only from the time it's instantiated and executed, and once it's done executing, then it's gone. So you can see that as the cloud evolves, things are becoming more automatic. Your unit of scale is becoming smaller and smaller and smaller. It's faster to deploy, and things don't stay around for long. It comes and goes quickly. So let's talk about staying competitive. That's the fourth key benefit that moving to a cloud architecture, especially a cloud native architecture, provides. On the left-hand side, you'll see a number of popular enterprise apps or enterprise technologies, and we'll be looking at the adoption and usage of those apps in a cloud environment. And at this point, the cloud environments we're looking at are either infrastructure as a service or software as a service. So you can see that if we combine the two, both are cloud type deployments, we can see that 60% of customers utilizing these type of applications are utilizing cloud-based versions. So that's big, and this is the situation today. Now, if we look on the right-hand side, we'll see Gartner's forecast of how they see the growth of the various cloud technologies. Infrastructure as a service, platform as a service, and software as a service. From the chart, we can see that over the next 3 years, the usage of the cloud will be growing significantly, roughly a 20% compounded annual growth rate. So that's massive growth coming to the cloud, and we already have large adoption of the cloud as it is today. So how does PowerBuilder fit in all this? How is PowerBuilder going to help you transition your existing systems as well as easily develop new applications for the cloud, and specifically cloud native that we've been talking about? So in terms of PowerBuilder's cloud roadmap, we have already released PowerBuilder 2017 R3 to the market. And the focus of this release was to transform the existing PowerBuilder native client, your desktop app, so that it could be consuming cloud-based applications. And the features that we specifically added to enable this key transformation is a new REST client and a new OAuth client. These two clients added to the native PowerBuilder application allows you to consume RESTful web APIs and perform authorization using the OAuth standard and tokens. So if you already have cloud-based apps in your organization, then with PowerBuilder 2017 R3, you can begin to transform your existing client-server apps to make use of your cloud-based apps or assets. Now, PowerBuilder 2018 is going to let you go further to the cloud. You're going to be able to create server-side cloud objects, not just the client consuming cloud objects that you might have developed with another solution. And to enable that, there are two key things that we'll be adding. Support for the .NET Core Server Runtime, which is Microsoft's open source, cross-OS, and cloud-friendly .NET implementation, as well as a new C# framework that will make development of C# cloud apps much more productive than other popular frameworks out there today. And if you're not looking to move towards a cloud-native architecture and simply want cloud-based apps, then PowerBuilder 2018 is giving you a relatively complete server-side solution. In PowerBuilder 2018 R2, R3, we plan on going beyond a traditional cloud and enabling cloud-native apps. And to do that, we need support for microservices as well as integration with Docker to make it easier for you to develop cloud-native applications. So at this point, you'll be in a pretty good position to develop cloud-native applications with the productivity of PowerBuilder. And this is not far away from where we are today. But we don't plan to stop there. AWS is one of the leading cloud service providers, and they have a strong offering with their cloud-specific native services. So in PowerBuilder 2021, we want to support AWS Specific Cloud App Development in addition to the cross-cloud app development that we introduced in PowerBuilder 2018 R2 and R3. And another important feature that we want to add in PowerBuilder 2021 is Desktop Cloud App. And this is essentially taking the PowerBuilder Cloud Client of PB 2017 R3 and transforming it so it's easier to deploy and update from the cloud, so you have a more cloud-friendly client for your cloud server objects. Now let's take a look at PowerBuilder's cloud-related features. In PowerBuilder 2018, we mentioned we're going to be providing support for the .NET Core server runtime. And this really has four aspects to it. We'll be providing a target for creating C# web APIs against the .NET Core. You'll also have the option to create a C# assembly project type, again for the .NET Core. We are also introducing an OAuth 2 server. So this allows you to take advantage of OAuth authentication for your C# web APIs. And you'll be able to create that with ease in PowerBuilder. And also we're providing a C# unit testing target. Now that's not to say you cannot use any of the .NET testing frameworks that are out there. You can. PowerBuilder is all about open standards. But what we've done is we've integrated one of the most popular .NET testing frameworks into PowerBuilder 2018, and through our wizard make it very easy for you to integrate that. So PowerBuilder is all about simplifying these tasks. The second key feature we're providing in PowerBuilder 2018 is the C# framework, which I briefly touched on in the previous slide. The C# framework includes the following four key components. It includes a data store, which is essentially a spitting image of the PowerScript data store, except that you'll be scripting it in C#. We're also providing a model store, which is, I would say, a kissing cousin of the data store, but it has no dependency on the PowerBuilder IDE or the data window designer. It can be developed in Visual Studio or even a text editor for that matter. We're also introducing Model Mapper, which is a totally new data object or data container that is transaction focused. And it makes it far easier to build transaction-based applications with greater productivity. And also SQL Builder and Executor, so that we eliminate the need for you to hand code SQL. So as I mentioned, we had introduced a native PowerBuilder client in 2017 R3 and added features so that it could act as a client for your cloud-based applications. And we're improving upon PB 2017 R3 in PowerBuilder 2018. Specifically, what we're adding is the ability to use the REST client object to do an update. In PowerBuilder 2017 R3, only retrieving data could be handled through the REST client. And for updating data, you would have to use the HTTP client, which required much more coding. The beauty of the REST client is with simply one line of code, you can do either a retrieve or an update of a data window against the C# Web API. We're also introducing zip and unzip capability for the HTTP client. So if you're moving large amounts of data, you can compress that to minimize. And we're also introducing JWT token support. So you already do have OAuth tokens, but you'll also be able to take advantage of JWT tokens as well. So in PowerBuilder 2018 R2, R3, we will be providing support for microservices. That's one of the key characteristics of a cloud-native app. Now, you're able to do microservices in PowerBuilder 2018. It's not that you can't, but what we're doing is simplifying it. This is adding value to the development process of microservices. And how we're going to add value? Well, we're going to take care of the scaffold generation of your cloud-native app and of the microservices. For those of you not familiar with scaffold generation, it's essentially creating starter code and a skeleton so that then you can focus on actually doing your business logic rather than a lot of nuts and bolts or plumbing. We also want to provide support for Docker. And again, it's not that PowerBuilder 2018 is not compatible with Docker. It is. You can use Docker today with PowerBuilder 2018. But we want to make it easier for you to work with Docker because, again, container packaging is a key part of a cloud-native application and that architecture. So to accomplish this, the first thing we want to do is offer you IDE integration. What that means is from the PowerBuilder IDE, you'd be able to build, run, debug, unit test, and publish to Docker. And also we want to provide you the ability to create an app Docker image. Now in PowerBuilder 2021, we want to support AWS serverless. So this is taking the cloud native that you're able to do in R2, R3 and giving you an AWS specific implementation. Now that doesn't mean you cannot deploy a PowerBuilder 2018 R3 cloud native app to AWS. You can, but it would not be necessarily making use of the AWS specific features unless you hand coded that. We want to provide a seamless project that is specific to AWS services. So that would be providing scaffold generation for serverless app as well as Lambda projects of AWS. And also we want to provide integration with AWS, specifically the PowerBuilder IDE being able to build, run, debug, unit test, and publish serverless apps. And lastly, in PowerBuilder 2021, we're looking to provide you a desktop cloud app. This is a native PowerBuilder app that we want to transform into a desktop cloud app. So you'd still be scripting in PowerScript and having all those features you love about PowerBuilder, such as the data window. But compared to a traditional PB app, a desktop cloud app has three unique capabilities. First, these apps are deployed over the internet and update over the internet. It's not a traditional client-server deployment. The downloading and updating of these apps is just in time. So you don't need to bring down a few hundred megabytes to start to use the application. And when there's an update, it incrementally updates. You don't need to refresh the entire application. So that's very different than the current client-server deployment. And another unique characteristic is that a desktop cloud app does not directly talk to the database. Everything is done through C# Web APIs. The middleware, or the cloud server, is talking to your database. So just to clarify, client-server applications are remaining. We're fully supporting enhancing that. But really, we're looking to introduce a new native PowerBuilder client that is very cloud-friendly. And we'll be offering client-server migration solution so that if you're looking to take an existing project and migrate that to a cloud app, you'll be able to do that with the least cost and effort possible. Thank you very much.